So this is stability bit versioning. I'm Richard Feldman. This is going to be a very low-key talk. It's about a very small idea. And this is an observational versioning system in that I've observed it and I decided to give a name to it. All right, so this is Donald Knuth. A show of hands, who knows who this guy is? Yeah, so he's developed a lot of things in his career, one of which is that he's probably most known for is tech. So this is like a layout typesetting engine that is widely used in like academic papers. If you've ever read a computer science paper, chances are it was laid out in tech. So he like released it, released version 1, released version 2, released version 3. And starting with version 3, the version numbers got a little unusual. So after 3 came 3.1, then 3.14, and then 3.1.4. So they're approaching pi. And this is intentional. This is how they're going to be versioned from now until, as Knuth said, until the day he dies, at which point he has said he wants tech to be declared version pi and no longer release any more updates. From then on, as he put it, all bugs are features. So I thought this was really interesting. This is like this idea of like planned stability, like a really, really hardcore notion of stability. And he says, yeah, you know what? I strongly believe that an unchanging system has great value. Let us regard these systems as fixed points, which should give the same results 100 years from now that they produce today. Okay, that's what he said in 1990. Well, I guess time will tell if that ends up being true, but it's certainly an interesting idea. So I was thinking about this in the context of software releases that I do and that people I know do, right? So usually you're doing some sort of like bug fixes, or maybe the interface expanded, like if this is a library or a framework or a language, or maybe the interface changed, and we kind of tend to say, okay, well, non-breaking changes are sort of like minor and patch versions, like when we fix bugs or we expand the interface. But if we change the interface, like if we take something away, or if we change the types or change the names, that's going to be a breaking change. And there's a few different ways that we do version numbers. So we have like the old timestamp model of like Office, and also like cars do this, Office 2019, Windows 98, Windows is the whole versioning thing. I mean, or just sequential, we just keep incrementing it, right? Like Toast 17, next one I think will be Toast 18, we can safely predict. And then sometimes we have this like sequence and compatibility. So like you have multiple version digits, and each of them mean different things in terms of backwards compatibility. Of course, a really popular one of these is semver. So in this Linux example, we have like the 2 is the major version number, that first one. So that's like if there's a breaking change, we're going to increment that. Then we have minor, which means like the interface expanded, and then patch, which means like we didn't change the interface at all. And then optionally, semver allows for like maybe like a label for like pre-release metadata. So like either another number, or maybe like a beta or an RC1 or something like that. So what's interesting about this is to think about these in terms of stability, right? So nothing in semver, or really any versioning system I've heard of, really talks about stability in the Knuth sense, like any kind of promise about what's going to happen in the future. So, at one end of the spectrum, you have like, okay, there's a new version. Anything could change, and like best case scenario, I'm going to bump the major version number if stuff changed in a breaking way. And then at the opposite end of the spectrum, you have Knuth saying no changes, no new versions ever. But in between, we have this idea of backwards compatibility, and sort of like, okay, we made a new release, we are intentionally making it backwards compatible. So this brings me to stability bit versioning, and this is the term that I've come up with for some projects that I've observed, where they basically treat, it's like semantic versioning, but the first digit is a bit. It's a 0 or a 1, and they never go above 1. Once they release 1.0, they say, you know what, that's it. No more breaking changes. From now on, we're going to be backwards compatible. So it's like semver, but the first digit can only be 0 or 1. 0 means we're going to allow breaking changes. So this is maybe like in the alpha or beta period. And then the 1 means no more breaking changes. From now on, we are backwards compatible. We are committed to that. So for example, here we have like a 0 bit is either 0 or 1. 0 meaning unstable, 1 meaning stable. If the first digit is 0, then the meaning of the second digit is like this is a non-breaking change. If it's a 0, then the first digit is a breaking change. So you can say like between O.1.1 and O.2.0, that's a breaking like alpha release. It's sort of like semver shifted over by 1. And then if it's a 1 in the first position, then it's like minor and patch, just like normal semver. So as an example, so this would be a non-breaking change, but it's saying this is an unstable interface. Like the first digit being 0 means, hey, this is unstable. We're going to make breaking changes. This is not going to be backwards compatible territory. We're not making any Knuth-like promises here. Whereas in this versioning scheme, the first digit is called a 1. That means that we are in stable mode. Like we're saying, yeah, you know what? From now on, we're not going to make backwards incompatible changes. So as far as I know, I don't know of anyone who has called this stability bit versioning, except for me in these few minutes. But it is something that I have observed in a few different contexts. Like, for example, Java. It seems pretty safe to assume that at this point they're not going to make backwards incompatible changes because it's been out for so long. Rust has made a pretty public commitment to this. Clojure creator Rich Hickey has been really adamant that he thinks that breaking changes are broken and a bad idea. And so I think it's interesting to sort of give this thing a name and see if people would like to commit to it using that name as a way of saying up front, hey, I'm not just following semver, I'm following stability bit versioning. So please consider this as something potentially interesting for your projects. Thanks.